In this video, I'll be covering question 4, part B from the 2019 AP Calculus AB free response no calculator allowed section of the test. I cover A, B, and C all in their own videos, so if you want to see the other solutions, please check out my other videos. All right, so on B right now, it's telling us when the height of the water is 3 feet, the rate of change of the height of the water is increasing or decreasing. When I see terms like increasing or decreasing, that really has to tell me that I'm talking about really first derivative information. And so when you're trying to wrap your head around this, kind of keep track of if you had f of x was your original equation, then when we took the derivative of that, that told us if it was positive, that if we had a positive derivative, our graph was increasing. And if we had a negative derivative value, then our original graph was increasing. So that this derivative information tells us about the original function, what that was. So on this problem, if you kind of start putting the pieces together, your original function, so this is the rate of change of the height of the water with respect to time, dh dt, so that would be this function here. That's behaving like our original function, so negative 1/10 square root of h. And if we take the derivative of that function, d2h over dt squared, that if this value is positive or negative, that's going to tell us whether the original function we were working with, whether that rate of change was increasing or decreasing. So really what we're looking at here is the need to take the derivative of dh dt. And when we take the derivative of this, after we take the derivative of dh dt, then we'll plug in a value, specifically the value of the height happening at 3. And when we do that, if it's positive, that tells us that the rate of change was increasing. If it's negative, that tells us that the rate of change was decreasing. So when we go to do this, this will be implicit differentiation. Before I go to take the derivative of any problem, I always stop and I need to look for any rewrites. And there's a handful of algebraic rewrites that you always want to be on the lookout for. This is the one where we have x to a power inside a root. Anytime I have a root in a problem, I always want to rewrite that as x to the power divided by the root. So if I had something like the cube root of x to the 5th, I'd want to rewrite that as x to the power of 5 over the root of 3. So on this, I've got a square root, which has an unwritten 1 for the power and an unwritten 2 for the root. So the first move out of the gate here before we take any derivatives is going to be to go ahead and rewrite that as h to the power of 1 over the root of 2. So that was just a rewrite only. We did not take any derivatives. Now to find our derivative here, this is when we're going to have to apply our implicit differentiation method again. We're going to need to dt this thing. And my saying that I use when I'm doing implicit differentiation is every time I take a derivative, I get extra stuff. And what that extra stuff is going to look like is, envision there being this little box behind that ddt right there. I'll take the derivative how I normally would, and then I fill that box in with the letter of whatever I took the derivative of over dt. And so let's go ahead and see how that works. So first and foremost, I go to take the derivative of my derivative. This is really just a notation game. You can kind of see d and d, that's how you end up with that d squared h, and then dt and dt is how you end up with that d squared on bottom. Then coming over here and taking the derivative of this piece, the negative 1/10, that's just a constant. That's going to come along for the ride. And then we do our power rule here. I'm going to bring the power down, and then I subtract 1 from the power. And then I took a derivative, so I get my extra stuff. I took the derivative of an h, so I get a dh dt. So there's my derivative. That's getting me down to this portion right here. And now what I'm going to need to do is I'm going to need to plug this value into that derivative and get out whether it's positive or negative. Before I do that, it's usually kind of helpful to kind of clean this thing up a little bit. So this would be negative 1/10 times 1/2 is going to get us negative 1/20. I always tell people square roots or negative exponents are great for doing derivatives. They're horrible when you need to start doing calculus. And so what I would do here is I would push this h to the 1/2 back down to the bottom and then multiply that by dh dt. Well, I don't have a way right now to plug in h into this dH/dt, and that's where I come back and I say, oh yeah, dH/dt is its own little formula here. And so I would go ahead and I would substitute that formula back in. So this is negative 1 over 20 h to the 1/2, and then instead of dH/dt I have negative, that should be a negative up front there, negative 1/10 the square root of h. And so one of the quick things you can do here is you'll notice that this is h to the 1/2, which is the same as this. And so I actually can save myself the time of having to plug in because I'm multiplying, those two things will cancel. And now I'm just looking at a little bit of multiplication. I get negative 1/20 times negative 1/10. So out of there, I'm going to get a positive 1 over 200. This is a positive value, and so that tells me that my rate of change is increasing in this situation. So because my second derivative is greater than 0, I know that my dH/dt is increasing. And maybe you bring that all back together in a final explanation. You would say d2h over dt squared is greater than 0. So my dH/dt is increasing at h equals 3. And that would be your final answer. You would have gotten 1 point out of here for getting your derivative proper out of the starting point, getting that second derivative, or actually I guess 1 point from putting this little work together showing that you needed to take the derivative, 1 point from then getting that second derivative proper, and then 1 point for getting your final answer with the right justification with it. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.